Welcome back to Topic 13 for Algebra 2, Graphing Linear Inequalities. In this video, we're going to learn how to graph linear inequalities on a coordinate grid so we can ultimately learn how to graph systems of inequalities on a coordinate grid. So, some things to keep in mind before we get started. Whenever we have a less than inequality sign, when we draw our line for our inequality, this will be a dotted or like dashed line. And since it is less than, when we shade, because remember we shade for our solutions, we're going to shade below the line. On the other side of things, if we have a greater than sign, this is also going to be dotted, but we're going to shade above the line for our solutions. If we have greater than or equal to, so see how we have this or equal to bar, that means those points on the lines could be solutions. So think about this as kind of like a closed circle versus open circle. Dotted lines is those points on the line are not considered solutions, whereas a closed circle or a solid line, those points on the line are considered solutions. So since it's also greater than or equal to, we're going to shade above the line for our solutions. And whenever we have less than or equal to, this is also going to be a solid line because remember, or equal to. But we're going to shade, but we're going to shade below the line. So before we move into some problems, some things to kind of also keep in mind are whenever we deal with our linear inequalities and graphing them, it's easiest in my mind to graph them when they're in slope-intercept form. So whenever we have y equals mx plus b. So if it's not already in slope-intercept form, please convert it so it is. Unless you feel comfortable with standard form, by all means, go for it that way. I just think slope-intercept form is the easiest. Then you plot the y-intercept and use the slope to find two or more points on the line and kind of count off using the slope. Again, this is just like graphing in topic 8. And then connect the points with either your solid or your dotted line. So that's kind of a key part to make sure that you remember. Oftentimes students just are so used to graphing a line that then they do a solid line. But what if they have a less than equality or greater than equality? That would be dotted. So just make sure you keep an eye out for that. Then do your shading either above or below the line. And then something that I think is also really helpful is checking if you shaded in the correct spot by plugging in a point. And we will see that in our first example. So our first example here, we have y is less than or equal to 3x plus 1. This is already in slope-intercept form, so we can just graph it as is. We're going to find our y-intercept, which is positive 1. Our slope is 3 over 1, so we're going to rise 3 over 1, rise 3 over 1, rise 3 over 1. And we can also fall 3 into the left one if we want to extend it in the opposite direction. Now, because right here this is greater than or equal to, we're going to have a solid line. So now I can connect my points with a somewhat straight line. Also, because it's less than, we can shade below. So we're going to shade over on this side of the graph. Now, if you're ever a little bit unsure whether you shaded on the correct side, you can test a point. So a point that I usually love to test is the origin, 0, 0. Here, we can see that 0, 0 is on the right side of the graph. Now, if you plug in this point into the inequality and the statement still is true, then you know that you shaded on the correct side. If you plug in the value into the inequality and it is not true, then that means you need to shade on the opposite side. So, if it's easier for you to choose a point where it is clearly like in the shaded section, such as over here, feel free to do so, but I just think 0, 0 is easiest. However, if you ever have a graph and it goes through the origin, I recommend choosing a different point because it's easier than to decide where you need to shade, if either above or below, if your point is not the origin, if your graph already goes through that point. So all we do, this is your x, and this is your y. We're just going to plug in. So we have 0 is less than or equal to 3 times 0 plus 1. And this simplifies to 0 is less than or equal to 1, which is true. So we shaded in the correct spot. If we move on to the next example, here we have 3x minus 6y is less than 18. This is standard form, actually. So it's not in slope-intercept form, but we can make it into slope-intercept form. We want to isolate our y, so we can subtract 3x on both sides. On the left-hand side, it reduces, so we get negative 6y is less than. Now, this could be 18 minus 3x, or this is a positive 18 if we want to think more of it in like slope-intercept form to make our lives a little bit easier moving forward. We can have that negative 3x come first and then add that 18. Then we're going to divide everything by negative 6. Remember, everything gets a negative 6. On the left-hand side, it reduces, and we get y. Then negative 3 divided by negative 6 is going to be positive 1/2 x. And 18 divided by negative 6 is negative 3. However, here, because we're dividing by a negative number, instead of less than, we're going to change to greater than. So it flips. Remember, think back to, what was it, topic 3? It flips because we divide it by a negative. Whenever you multiply or divide by a negative, your inequality sign needs to change. So now we can graph this. So our y-intercept is negative 3, and we're going to rise 1, run 2, or fall 1 to the left 2. Now, because this is just greater than, this is going to be a dotted line. And since it's greater than, we're going to shade above. So again, we can test a point just to make sure. Let's test the origin. So we will get 0 is greater than 1/2 times 0 minus 3, which just says that 0 is greater than negative 3, which is true. So we are all good there. Moving on to our last example, we have y is greater than or equal to 1/2 x minus 4. Now this is already in slope-intercept form, so we can just graph it on our coordinate grid. So our y-intercept is negative 4, and our slope is positive 1/2, so we're going to rise 1, run 2, rise 1, run 2. We can also extend our graph in the opposite direction by falling 1 to the left 2, falling 1 to the left, falling 1 to the left, falling 1 to the left. This is going to be a solid line because it's greater than or equal to. And since it's also greater than, we're going to shade above. We can also test a point. Let's test 0, 0, because it's nice and easy. 0 is greater than or equal to 1/2 times 0 minus 4. This says that 0 is greater than negative 4, which is true. So we shaded in the correct area. That was part 1 for topic 13 for Algebra 2 on graphing linear inequalities on a coordinate grid. Thanks for watching.